Hi, Math 114. Welcome to the impromptu Zoom session. I plan to go over a little bit about 4.2, and maybe if any of you join me, we could talk about 4.3 and 4.4. Right now, I'm just hanging out to see if anyone is there, so I'll come back in a minute. If I need anything, I'll start kind of going over a few extra examples I planned out anyways. Hello.
Hi.
Welcome. I'm just hanging out. I'm glad you made it. I'm just going to go over a few 4.2 stuff, but if you have any specific questions, I could definitely hit those up first.
Okay, that's fine. It's because I was doing the homework earlier and I got kind of stuck, but I kind of figured it out because I looked at the notes.
Okay. All right. Sounds good. So let me see. If maybe we'll start from the first part of the 4.2. Let me see if I can share my screen with you. I think you might see it now. I'm going to move the bar out of the way. My settings, make sure. Let's move that a little down here. Okay, so I'll start from the nicer versions, and then I'll go to the increasingly rougher ones.
Okay.
And then just stop me whenever you need anything. So you should be seeing, it looks like graph paper right now. Let me see if I can test out, see if you can see my writing. Moving the little bars around is going to be a little difficult. There we go. Hello. We're just getting started. Okay, so let me see. Let me go over, start with the 4.2. Make sure everyone is here. I'll get that out of the way. Okay, so I'm looking at maybe using the sine analysis to solve these 4.2. Just making sure, is everyone seeing the screen okay?
Yeah.
I just wrote a 4.2. You can see that?
Yeah.
Okay, cool. All right, so if we're using the sine analysis to solve rational inequalities, let me write that down so we have a nice visual. Let's start off with maybe the difference between just kind of seeing them in nice form. So if we saw something like x minus 9 over x plus 4, we'll say. And I'm going to look at maybe seeing that when is this greater than or equal to 0. And this is kind of nice if it's already set in its form. When it's already compared to 0, that's kind of what we want it to look like before we do any sort of sign analysis stuff. So the first thing we want to do is we're going to look at boundary point. And that is done by setting the numerator and denominator equal to 0. Very nice. So I'm going to see if I can write that down. So that's a x minus 9 equals 0, which is going to give us x equals positive 9. So that's one of the boundary points. And then the other one, I'm going to set the denominator equal to 0. So the denominator is x plus 4 equals 0. That's going to give us x equals negative 4. So there's two boundary points in our particular rational inequality. And the next thing I want to do is graph these guys on a number line. We're going to say graph on number line. So far, so good?
Yeah.
Awesome. Okay, so I'm going to set the number line up to the side. I guess it'd be to your left. And I'm kind of leaving enough space on the left side so I can write the factors down. But right now with the number line, I'm going to plot the 9 and the negative 4 in relation to each other. So that would be like the negative 4 on the left of the 9. It doesn't really have to be to scale, but I just want to make sure that they're in the right order. So once you plot it, you can break up your number line into, this will be 3 different parts or 3 different regions. And then what I always do after that is I list the factors on the left. So the factors that I see an x minus 9. I'm going to kind of put it over here. And then I also see the next one is the x plus 4. I'll put that right below it. Might as well keep it consistent. And so that's going to break the regions up even further and give us 6 different spots that we get to test with the test point. So we graph on the number line. We write, besides writing the numbers on the number line, we're going to write the factors to the left of the number line. And trying not to get them confused with the 3 different regions. So just so I can see if I can, maybe can highlight, there's a region from negative infinity to negative 4. There's also a region from negative 4 to 9. And there's also a region from 9 to infinity. And so those are the 3 different regions we're going to test out. It doesn't have any relation to the highlighting that I just did for the x minus 9 and x plus 4. So I just want to kind of show from there. So now what we're going to do is we're going to pick a test point for each region. Usually it's like a number. And just make sure that when you're kind of picking the numbers, they fall in the particular region. So for example, if I'm looking at the region on the very left, and it's the pink highlighted region. Any suggestions?
Negative 10.
Negative
10.
Negative 10, perfect. I like negative 10. So I kind of mark it a little bit just so I know. So I'm testing x equals negative 10. And that's for the pink region, just so that we can see that. And you just plug those numbers that you just tested into the 2 factors on the left-hand side. So I'll just show it out just in case. If you're plugging it into x minus 9, that would leave us with a negative 10 minus 9, which would give us negative 19. And what we want to get from that is the fact that it's just a negative number. So I don't really care whether it's negative 19. But that allows me to put a negative sign in the region where I tested. In the same sense, if I'm still testing x equals negative 10, I'll also plug it into the x plus 4. I'll kind of separate that for you. So that also gives me negative 10 plus 4, which is a negative 6. I guess it doesn't matter what the number, but the main thing is that we're getting a negative sign there. So far, kind of okay?
Yeah.
Yes.
Okay, cool. So what we do, if you prefer to and you like to write out the regions, it's fine with me. Sometimes you get a little bit faster and you start getting a little bit more into the mental math. So if I were to pick a region in the, a number in the middle region, the yellow region, any good advice for me?
The 0.
Yeah, I like 0. It's very nice. So if I do that, I know it falls in this region, and I can say, okay, if I'm plugging it in, I would say 0 minus 9. And that will give me a negative number. Excuse me, I'm gonna let my dog outside. I'll be right back. All right. There you go. Good girl. Okay, so 0 minus 9 gives me a negative number, so I'm going to plot that into the same region where the x minus 9 is located. And then also I'm looking at 0 plus 4, which also gives me a negative number. Excuse me, it's a positive number.
Positive.
Yeah. Okay, so that's the first time I get to now plot a plus sign in that particular region. So far, so good?
Yes.
Okay, so just one more thing with the next test region. We are going to look at any number that comes after the number 9. So suggestions.
10.
10, perfect. So I like 10 a lot. We're going to test x equals 10, and that is in the turquoise region. They say teal. Okay, so then I'd be plugging in 10 minus 9, which gives me a positive number. So that's going to give me a positive sign at the top right. And then I'll also plug in a 10 plus 4, which gives me a positive number as well. So I get a positive number in the bottom, I guess it'd be bottom right on there. So you can, to keep track of things, you could kind of plug in all the numbers and write it down. But a lot of times this part, if the numbers are nice enough, we can use mental math to figure out whether the regions will be positive or negative. So far, kind of okay?
Yeah.
Okay, so now, after we do that part, the last thing is we need to figure out the sign of each region. So find the sign of each region. And by doing that, you're usually multiplying the two signs vertically. The reason why we do multiplying is because when you look at the two factors, they're being divided. And division with signs is the same as multiplication with signs, so I just kind of use multiplication. So I'm going to be looking at negative times negative, which gives me
Positive.
positive. And I always like to circle that sign if I'm not color coding it. It helps you remember that that is the sign of the entire region. I have negative times positive, which gives me
Negative.
negative. I circle the sign of the region, and then positive times positive, which gives me
Positive.
positive. Okay, so now that we have that, most of the work is done. We just go back to the original inequality. See if I can, I think you guys can still see it.
Yes.
X minus 9 over x plus 4. We're going to look at this, and this is another way to say where are the regions. So greater than 0 means positive number. So we're kind of asking ourselves, which regions did we find the positive signs? And the question, or the answer to that, it looks like there's a pink region that we'll be answering. This pink region right here gave us a positive region.
Mm-hmm.
And also the teal or the turquoise region is also the positive as well. So now
I have a
we
question.
have a, Oh yeah, what's up?
Oh, if the sign was flipped the other way, we would be looking for the negative?
Yes, exactly. So
Okay.
that would give us the yellow region. And I'll write that down too at the bottom of this so you know you're actually getting 2 problems for the price of 1. If I'm going to name what my solution is, that's kind of the last step. After we find the sign of the region, we then determine the solution of the inequality. And I'll go back up. I really like looking at my sign graph. Finally, for number 6, my solution. I know we can just say, hey, it's pink region and turquoise region, but if we want to be a little more mathy about it, we're going to name in interval notation. The pink region is coming from negative infinity until where? Where's the stopping point? Negative 4.
Yeah.
And I know infinity always has the parentheses. What I want to be really careful about is that you guys see that there's the inequality symbol that says greater than or equal to.
So that has a bracket, right?
It would normally, but when we kind of look at the denominator, let me kind of highlight that. I'm always looking for a different color. Maybe I can go here for a second. See if I can highlight it. There we go. Any number that makes the denominator 0 ends up not being able to be included. So what goes on is now this -4 would actually have a parenthesis, and that's because it makes the denominator 0. And it's kind of a very small detail. Like I'm really happy with you guys knowing the whole sign analysis method and knowing which regions to pick. This is kind of not the battle I'm going to pick with you, but it's kind of a detail that ends up being important with making something undefined. So I kind of have to leave it in there in terms of, maybe if it were a test problem and it were worth 10 points, you would have at least 9 points out of 10 for getting the right regions. And then this little detail on the side is kind of more of, the A plus instead of an A. So don't stress out too much, but it is still kind of important. So that's the reason why you're using the parenthesis on that one. But when we look at the other winning region, the turquoise region, it's split up. So I do know we have a union going on. We start up again at 9 and then go all the way out to where?
Infinity.
Infinity. And so infinities always have the parentheses. And this time, when you kind of look at where 9 came from,
This one has the bracket, I think.
Yeah, it came from the numerator. So that's why we get to use a bracket. And it kind of goes in line with everything. I'm sorry, my dog is freaking out. Let me let her back in. Okay. There you go. Go lay down. Go lay down. Okay. All right. So now we have the final solution of our inequality. And that's kind of where the sign analysis method comes in. And then I think what you guys said earlier is the question would be, what if, I'll do this in green. So what if the original problem was asking if the x minus 9 over x plus 4 was less than or equal to 0. And so this issue would be, well, we just go back to the original graph and we say, oh, okay, if we are understanding what does it mean to be less than or equal to 0, we're kind of asking ourselves not where we're positive anymore, but where are we?
Negative.
Negative, yeah. So then when I go back, I'm looking at the yellow region now. Kind of where I'm kind of going back and say, oh yeah, that's where we got a negative sign. So if we're going to name what the solution is going to start off with 4, or -4, and go all the way to the 9. And we just got to remember, based on whatever made the denominator 0, the -4 should have now parentheses. And I'll highlight that again just as far as the color is concerned, so you guys can see where that came from. -4 made a denominator 0. And then the 9 is still good to go. It should have a
bracket.
And so that kind of, in the nutshell, is what you're looking at for when you're using the sign analysis method to solve these rational inequalities. So that's kind of a nicer, I know it seems like there's a lot of steps. That is considered the more straightforward one, believe it or not. But the goal is to get it to look like a fraction being compared to 0 before you even start dealing with sign analysis stuff. Most of the stuff, I guess if you're going back and looking as you're working through maybe the test, you now have a nice set of directions to help. I think what I want to look at is if what happens if you don't have a 0 already. We have to go through a little more algebra to get it to that position. But so far, do you have any questions on the process, or why something works out a certain way versus why something doesn't? Or
For me, the only problem is with the homework. It's the equals to, where it's like 5 over x plus 2 equals 3 over x plus 2.
oh, okay, let me get that. Let me do one more with seeing if we actually had an actual number besides 0 here, and then I'll hit that problem up, and it's very similar, and then I'll do the whole solve the equation and the related inequality.
Yeah,
So I could definitely help with that. That's definitely something on there, and I'll relate these two problems together.
Okay, thank you.
So let's say you had, so one more thing. So let's say we had, what if we had x minus 9 over x plus 4 is greater than or equal to, let's say the number 2. Okay, so the first thing I kind of notice is that it must be compared to 0. So the rational expression, or the fraction, what I'm trying to say, must be compared to 0 before we start doing any sign analysis. So if that's happening, the first thing we got to do is we play with a little bit of algebra on this one. And
More than -2?
Yes, good. All right. You're right. So you're going to subtract 2 from both sides. And that 2 has nothing to do with our fraction. So let me just color code it so you guys can see it a little more clearer. We have this x minus 9 over x plus 4, and it's -2. And then now it's all greater than or equal to 0. So that's the first part. So that's a little bit of algebra. But then before we move on, we need to have a single fraction compared to 0. So we still need to combine this over common denominator. Before common denominator, before we can do any sign analysis stuff. So this is where we run into the whole LCD stuff. So we have to first understand that the 2 can be placed over the number 1 to make it look like a fraction. And we still have to find the LCD. And luckily with these, it's kind of, there's only one other denominator other than the number 1. So the LCD for these two numbers or expressions would be x plus 4. And then you just have to make sure you're rewriting each fraction so that it has the LCD as that particular denominator. So how they say that is we're going to rewrite each fraction so that it has the LCD as its denominator. And that's kind of building up to higher terms. We're making equivalent fractions. That's what they kind of call it. Let's spell that right. Equivalent fraction. So you can't just give it an x plus 4. We have to kind of make sure that we are doing this legally with math. When I'm looking at my two numbers, the first one, x minus 9 over x plus 4, that is good to go. That's taken care of because it already has an x plus 4 as a denominator. Mm-hmm. What needs to happen is that the 2 over the 1 does need an x plus 4 in the denominator. And that's the case of whatever you do to the denominator, you do the same thing to the numerator. So this is where we're running into. That's kind of the math behind that. So you kind of clean this up just a little bit. I'll keep the steps going because it does help to see. I have x minus 9 over x plus 4 minus, and however you want to do this, I'll keep the minus sign for now. But the new part is us saying, okay, the 2 had to be distributed to the x plus 4. So that's going to give us 2x plus 8. Very nice. And then the denominator is good to go. And then I still have this inequality symbol. I'll keep that in the mix, still greater than or equal to 0. I just want to be careful with the minus sign though. We can take care of this all at once if maybe you decided to then distribute the negative sign with the 2. Mm-hmm. But just in case, if you want to go back and look at the details, I kind of left it like this. So like an extra step just to help with a little bit with the algebra is that now that they have the same denominator, the numerators get combined. And what's actually happening is we are subtracting off the 2x plus 8. And still have this greater than or equal to 0 part. And then what goes on is the work ends up being now you having to simplify the numerator. So as we're simplifying the numerator, we've got to distribute the negative sign. So if I do that, that's going to give me a negative 2x and I believe a minus 8. And then after we do that, let me kind of write that step out just so that we can see where we left off. X plus 4. Move that up a little bit for you guys. Once we distribute the negative sign, the last thing we'll do is combine like terms. So if we do that, what should our new numerator be? Let's see. We should have, let's see, so x minus 2x will give me
negative x.
Negative x, awesome.
Minus 17.
And minus 17, perfect. And then still all over x plus 4, greater than or equal to 0. And then now, excuse me one more time. Okay. You go outside, you're gonna stay outside. Okay. So now we are in ideal form. So we're in the shape to actually start the sign analysis. Oops, let's see, right there, the right thing, analysis. So if we kind of look back, just trying to review when we go through this, we're saying, okay, the main issue here was having this number not be a 0. And so when that happens, a bit of algebra, when I say a bit, I guess I'm under exaggerating, or there's a lot of algebra that has to happen to put it in this nice form. But just so that we're going through this, when we kind of look at this again, it's not a bad one to redo the sign analysis method. We can then say, okay, I guess if we're ready to do sign analysis, we're going to say, okay, who are the boundary points? So let's see, boundary points. We're going to set each numerator and denominator equal to 0. And so I know the x plus 4 equals 0 gives me -4. That was kind of similar to our other problem. And then sometimes you get these strange, minus, minus. So just kind of take your time on this, just so that we don't make any of these minor mistakes. And we actually get -x equals +17. Or if we're dividing both sides by -1, that's going to give us the x equals, I believe it's -17.
Mm-hmm.
Yeah, just check me on that. Usually that's where everyone makes the mistake, is on that little part. You guys do a really good job of going through all the algebra, going through the sign analysis, and then it's one little thing that throws everything off. So like if you guys were doing this on the test, if it's multiple choice and one of the answers is not there, just make sure, like, oh, just check your math. Maybe there's something going on with that. So having said that, we can now graph them on a number line. And when we're graphing two negative numbers in relation to each other, we have -17, -4. Who should be on the more to the left?
-17.
You got it. Okay, so I got -17 over here, and then -4 somewhere over here. And again, with my sign analysis, you see me break up the number line into this. In this case, it's 3 different regions. I also throw my 2 factors that I see, or my numerator and denominator, into the mix to the far left. I guess it doesn't have to be on the left. I'm left-handed. Maybe it just seems more convenient for me. But anyways, you can make it on the right if you'd like. But now you have 6 different regions to try out. And then we could kind of play with maybe, let's see if we can do this mentally. If we're picking a number, we're actually testing in the far left region, anything beyond the -17. What do you guys think?
-20 maybe.
Sure. Make your life easier. So if we're doing that, then we're saying, okay, -20 minus 17, it's still going to be a negative number. Oh, wait, let's double check. I actually should not say that. I see that extra negative sign right here.
Mm-hmm.
This is what kind of gets me. So let me take a little time on that just in case. So I'm looking at negative x minus 17. There's a negative already from the expression. Aha. And so I'm actually plugging in -20 minus 17. So that is another like minor mishap that could happen. I can definitely see that if we're kind of going or rushing through this. But now that you have the opposite of -20, you actually have a positive 20. Eek. And then we are actually getting a positive number because 20 minus 17 gives us a 3.
Yeah, positive.
So I can't just do that right away. That sometimes those get me. I just gotta be careful. But I do know when I test the -20 inside the x plus 4, I'm kind of playing with that. -20 plus 4.
-16.
Give me the negative, right? -16.
Mm-hmm.
So right away I can do it that way. So I guess I'd be really careful about like when I see opposites of variables. Sometimes that's kind of an issue. And I think we have the same issue if we actually go in the middle somewhere in the middle. Let me see if I can undo that. I'll pick, kind of stay consistent with the color coding. If I'm testing a number that's in the middle of -17 and -4, what do you guys think?
-10.
Sure. Very nice. So we have -10. So then again, one more time, I'm going to be real careful. I'm actually plugging in the opposite of -10, then I'm subtracting off 17, and that has to do with that negative x part. So that should give me
-7.
-7, right? 10 minus 17. And we're not really concerned too much about the number, but I do care about, oh, there should be a negative sign somewhere at the top middle.
Mhm.
And then similarly for the x plus 4, we would have -10 plus 4, which would still give us a negative answer.
Yeah.
Okay, so I have a negative answer there. And then one more test point. We get, let's see where we get something that comes after, or I guess, yeah, something in the region from -4 and beyond.
Can you use 0?
Yes, definitely, because it's there. Yes, good choices. So actually, you don't have to. You probably can do this one more mental math. If you plug in x equals 0, then -0 minus 17 is still negative. And then 0 plus 4 is
Positive.
positive. So kind of sometimes we had a little sign switch going on there. So once I plot all those signs, I do the whole figuring out the sign of the region. I go positive times negative gives me negative. Then I do negative times negative, which gives me positive. And then I go negative times positive, which gives me negative. And most of the time, I believe in this class, there's a nice little pattern with the alternation. You alternate the signs. Just kind of, for the most part, that should work out most of the time. So if something goes wrong or you're noticing you're getting 2 in a row, maybe double check that. Different classes, maybe with different functions, you might have something to look for or something different to look at. Okay, so all of that, what's going on is we're going to go back to our original inequality. I'm going to highlight that. That's kind of, it's the one where we did all the algebra and we made sure that it was compared to 0. The next thing we're going to ask ourselves when we look at this statement right here, we're asking where are the regions supposed to be where? What would it be, positive or negative? So bigger than 0.
Positive?
Yeah.
Where positive, yeah. And when we kind of look at what our possibilities can be, there's only one region that has a positive sign this time, so that is in between.
So would it be like -17 and then -4? But like no brackets?
Let me see. So I believe you have the right region. So the solution is the pink region. You're right. And you're starting at -17, stopping at -4. And let me just double check. When I go back to the original inequality, which one makes the denominator 0?
4.
4, or the -4 part. So that's the one that's going to give us a parenthesis. Even though the original inequality had a greater than or equal to. And the one that's a 17? Bracket. And so we have our solution. Yay! But the other cool part, just kind of the side note, if you see this, the question would be, what if, when we're looking at our original problem, to go back to what it was, x minus 9 over x plus 4. X minus 9 over x plus 4. What if we had it the other way around? So less than, sorry, I'm scrolling. What if we had the inequality symbol the other way around? We did all of this work with the algebra, we don't have to do anything more other than kind of consider that this part turns into our negative x minus 17 over x plus 4 is going to be less than or equal to 0. Just want to make sure, are you guys okay with seeing how when you moved everything to one side, the inequality symbol really didn't have any effect on how the algebra, when you combined over common denominator, turns everything into the negative x minus 17 over x plus 4.
Got it. I got it.
So you already did all this work up here. We don't have to repeat ourselves. We just say, oh, yeah, when I look at the original inequality, I ended up getting the one we're using the sign analysis on, right here. It works the same way, even if the inequality symbol was facing the other direction. We just know, oh yeah, that just means it's equivalent to the negative x minus 17 over x plus 4 is less than or equal to 0. So there's no other work other than looking at your graph. When we see a less than or equal to 0, that's telling us to look for where our region would be what?
Negative?
Negative, yeah. And pretty much it's the opposite of what we just answered. So when we kind of look at our sign analysis or our sign graph that we made, there's no extra work other than we're not choosing the pink region, we're just choosing the other two regions. So if that is the case, we'd be choosing, as far as the solution is for this particular expression, we'd be coming from negative infinity, stopping where?
Negative 17.
Negative 17. And we'd be starting up again at
negative 4 to infinity.
Negative 4 to infinity. Sometimes I always like to put the infinities that have parentheses, and before I jump to conclusions, I go back and make sure when I'm looking at the original inequality symbol, I know that the default is to use brackets. So any number that doesn't make a denominator 0 gets to be a bracket. So that's where the negative 17 comes into play. But the negative 4 is the issue. It has to have a parenthesis. So you have your solution, two for the price of 1. Does that work for you guys?
Yeah.
Wait, but for the I thought it was a negative 4 with the bracket.
Let me go back and look.
Oh wait, because you said what it like has to equal 0.
Oh yeah. So remember, we're looking at when the denominator. See if I can. Let me write this over to make it a little cleaner. In both cases, I'm looking at negative x minus 17 over x plus 4 less than or equal to 0. So even though I see a greater than or equal to symbol, any value that makes the denominator 0 must be thrown out. Whoops, why is this not? There we go, thrown out. So that's where we're using the parenthesis on it. We do this by using parentheses. If we're dealing with interval notation. So when I go back and look at it, I see that, okay, it's this denominator that I'm dealing with. Negative 4, x equals negative 4 makes the denominator 0. So that negative 4 is going to have a parenthesis on it no matter what. So that's kind of that minor detail that comes into play whenever we see that greater than or equal to symbol.
Okay.
Really good for details, like I said, just kind of, it's not my biggest battle. I don't want to fight with you on this, guys. I don't want to be too picky, but like, just be careful. Maybe you move on to other math class, it's going to be a big deal. Like, it matters. And then it's kind of interesting because when it makes the denominator 0, you're actually talking about your vertical asymptote. You can't get rid of it. So if there's a relation to it in the graph, so it could help on that. So does that give a little bit clearer idea on using sign analysis method for these two types of problems?
Yeah.
Yeah, I got it.
Okay, great. And then I think you guys had the question about like what happens if like we just did a couple of problems where we had, let me scroll back just to make sure. The starting problem, we had it where it was compared to 0. So that was over the very first problem we did. Then the next problem we did, it was compared to a number other than 0. And then now what happens if we have like two fractions compared to each other, or we kind of tie everything in. So sometimes they'll say something like solve the equation. And its related inequalities. And that's the very last part of the very last part of the homework, I believe.
Yeah.
So something like, I'll give you a couple of them. 6 over x plus 3 equals 2 over x minus 7. That's one version. And then maybe part B, it's the same expression on each side, except now they have the inequality symbol. So it looks super intimidating, but we kind of piece it together. We can kind of say, well, in order to solve all of these, it's really kind of, I guess we'll save a lot of time if we start out with the inequality part and go with trying to find boundary points. Once you find the boundary points, you'll actually have the idea of what's the solution to the equation. So I'll kind of point out that the part A is the equation. Part B and C, we have the inequalities. And so it's kind of like 3 problems for the price of 1. But solving the inequality part first saves us some time. And then I'll kind of show you where that comes into play. So if we look, I mean, might as well just start with part B. I guess I'm more orderly. So we start with part B. Or, I mean, doesn't matter if you want to start with part C. But either inequality, that's going to help us figure out the solutions to the other 2 parts. The first thing I kind of notice is that I do not have an inequality. I do not have a comparison to 0. So notice the 6 over x plus 3 greater than 2 over x minus 7. There's no comparison to 0 yet. So that kind of gives me a hint that I have to make it happen. So if I do that, I'll rewrite it over again. So we have a little bit more space here. We have here, I have 6 over x plus 3 greater than 2 over x minus 7. This is where I'm going to go into the algebra of this. And in order to make a 0, we have to move one of the fractions on one side or the other. And usually people like to move everything to the left-hand side. It's kind of more, I guess we've kind of been trained that way. But when we move something in algebra class, we can't just move it. It's kind of adding the opposite. So what we're actually doing is we're subtracting off the 2 over x minus 7 from both sides. And when we do that, the left-hand side gets a little bit messy. We can't really do any combination of fractions until we have a common denominator. But now the right-hand side has that coveted 0. And that's kind of what our goal is, where we're really excited to see that 0. That's going to help us with that sign analysis part in telling when the function's above the x-axis, below the x-axis. But I guess you might be kind of concerned because now you're like, oh, this part, we got to do a little bit of LCD. Yeah, LCD stuff. Well, I shouldn't put a sad face. I should kind of, I mean, how do you draw a thinking face? That looks angry. Well, you guys figure that out. But yeah, you have to actually do a little bit of math there. And you are right. We need to combine over common denominator. And that has to do with, yes, the LCD and so on. So the cool thing about these guys in this class is that usually the denominators are only nice little binomials, or they're single numbers. So in our case, the LCD for these particular problems, well, there's only 2 denominators and they're not factorable. They're already nice and simplified all the way down. So the LCD in our case, we would just say, well, it's the combination or the multiplication of the 2 denominators. So once we do that, it's a little bit of extra work where we're saying, okay, the 6 over x plus 3, it needs something. What does the x plus 3 need?
-3.
It's going to be a -3 when we kind of play with some of the boundary points, but in order to turn this denominator, see if I can, this x plus 3 denominator into the LCD, it already has an x plus 3, so it needs what factor?
The x minus 7?
Yeah, it needs the extra, the x minus 7. So that's what I'm doing is I'm saying, okay, I have to give that fraction the x minus 7 as far as the multiplication is concerned. And this x minus 7, if I'm trying to turn it into the LCD, that's my goal. It already has an x minus 7, so it needs
X plus 3.
Yeah. So I kind of just take my time with that. I'm really big on color coding because it helps me see what I'm missing, but up to you guys. So just to kind of, I know that looks a little messy, but if I were to look at this a little bit cleaner, color code from, I actually am looking at the 6 times the x minus 7, and that turns my denominator into x plus 3 times x minus 7. I still have a minus sign, and I now have the 2 times x plus 3 over x minus 7, x plus 3, or if you write it in a different order, it's okay. But now we're interested in saying, well, everything is still compared to whether it's greater than 0. I just want to keep that greater than 0 in it. If I lose it, I get confused. So the idea at this point is you say, okay, they both have the same denominators. So at this point, we're going to say, I know at the end, when I combine them over a common denominator, I'm going to get the x minus 7 over the times x plus 3. That's my LCD. But in order for me to do this, and I'll be skipping a little bit of steps, but let me know, just stop me if you have a, like if you want me to know a step. I want to look at the, see if I can do this one. The 6 times x plus 7, the first thing I'm going to do is see if I can distribute. So that's going to give me
6x minus 42.
You got it. So I have 6x minus 42. And one of the shortcuts, and we can go the longer way if you'd like. I can show you the in-between step. But sometimes when you're saying I need to distribute the 2x plus 3, what you can do is you're saying, well, let's see if I could do teal. You could turn this negative sign into plus a negative and consider this all in one piece. So what I'm talking about is I'd be actually—
So it'd be like a -2 already?
Yeah. So you can kind of think about it that way, if you'd like. If that bothers you, just go with what we originally said. It takes one extra step, no big deal. But I can consider this a -2. So I have -2 times x gives me -2x.
-2x.
And -2 times +3 gives me
-6.
-6. So that's kind of a mini shortcut if you're interested. If that bothers you, just kind of go back the other way. And what I think we were looking at is perhaps just distributing only the +2 first, and then dealing with distributing the negative sign after. But just let me know. Can I clarify anything for you at all?
I'm good.
So far, so good. Anything else? Sometimes I know like it takes a while to process. Like I don't really get things when I learn until like the next day. So don't feel bad if you want to go back to it. I'm totally okay with that. Sometimes it takes me like a whole year to figure things out. That, you know, so don't feel bad at all. You guys are trying to learn like a year's worth of material in a matter of 18 weeks. So you should be proud of yourselves. So just want to make sure, is everyone okay with the negative 2x minus 6 part?
Yeah.
Good.
Okay, cool. So after we do this, we're just saying, okay, the work happens to be now in the numerator. So we just have to say, can we combine the like terms? And
Yeah.
yeah, so I have 6x minus 2x gives me
4x
I got 4x and then
minus 48.
Minus 48, a little larger number, but we'll go with it. Now I still have it all over the x minus 7
7 and
x plus 3, and I'm still looking at being greater than 0. But now I'm very excited because we now have a single fraction. I guess that's what I call it. And it's compared to 0. And that is good because that allows us to start our sign analysis part. So it's kind of a little more systematic.
Do we still need to simplify if possible, or do we just leave it like that?
If you prefer, you could factor, I know the 4 goes into both 4 and 48. Yeah. I tend not to worry about it, maybe unless it was like an x square factorization or something. Because sometimes the 4 gets thrown out and we get confused as to what's going on. So I may just leave it. I think the problem is when you factor it out. I mean, if you're saying, whoops, let me see if I can do off to the side. You could say it's 4 times, I think it's x minus 12. Yeah. Sometimes you have to account for this in the sign analysis method. So when you're making the number lines, you would have to have a 4, an x minus 12, an x minus 7, and an x plus 3 when you're doing your sign analysis. So it would further break up everything. Oops, how did that happen? Uh-oh, I want to go back. There we go. I wanted to make that a little smaller, but I guess now it doesn't do that. See if I can shrink that a little bit. There we go. So if you feel like you want to, it's fine. I think I usually get concerned if I see a quadratic, like a power of 2, x squared, x cubed, I may be more inclined to factor. But I can leave the 4x minus 48, but maybe it makes the numbers a little smaller. We could look at it. So what I'm looking at this point, after I have a single fraction compared to 0, I have my friend, the sign analysis method. And first thing I'm always looking for is finding the boundary points. And this process of finding the boundary points is going to give us one of the solution to part A. So that's the good news of going through all this. If we're looking at the boundary points, again, we're setting the numerators equal to 0. You'll still get the same thing as if we factored it out. And each of the factors in the denominator equal to 0, I'll label it. I'll kind of show you what I'm thinking. So this part right here, that's the numerator being set equal to 0. And this bottom part is the denominator being set equal to 0. Now with the numerator, you've got a nice little linear equation, and you're going to notice that if we factored it out, we would have still gotten the same thing. We could add the 48 to both sides. Let me make sure it looks a little prettier. And we would divide both sides by 4, and we're still going to get that x equals 12, yeah. And the question you guys had was really nice. You kind of can see that it does show up when you have the visualization, if you were to factor out the 4. So if you're interested in that, you can kind of go back and revisit with the extra 4 on the top. So that's one of the boundary points. And when we set the denominator equal to 0, we end up having 2 parts where you now have to say, okay, we have a product being set equal to 0. So that means we break up each of the factors and set those factors equal to 0, which ends up being 2 different solutions. We should have x equals
7.
a 7 and an x equals a negative 3. So we end up having 3 different boundary points. And now let me ask you this. Go back to the original inequality where it was compared to 0. Let me see if I can highlight that. I'm trying to pick my colors, but I'll do blue. So this particular inequality that we spent a lot of time on to make it compared to 0. And look at our 3 boundary points. And which ones of the boundary points are associated with our denominator?
The 7 and 3.
The 7 and the 3. So when I'm looking at them, I know that if x was equal to 7, I would have a 0 in the denominator, and 0 times anything gives us 0. And the same thing with the negative 3. So I want to make sure that these guys, if you know, they make the denominator equal to 0. And if that is the case, they can never be the solution. They end up getting thrown out no matter what, because anything that makes a denominator 0 makes a fraction undefined, and we have some issues there. Ends up looking at what our vertical asymptotes are, sometimes wholes. So when you're looking at the x equals 12, the process of you finding this boundary point, you actually solve part A. So we actually just played with the solution. So I'll kind of write that down. I don't know if you're going through the process, but this x equals 12 is actually the solution to part A. And that part A, if I can rewrite that over again, just so we see, let me see if I can remember what I said. Oh yeah, okay. So part A was the 6 over x plus 3 equals 2 over
X minus 7.
minus 7. Thank you. So the solution to the equation is just a number. So it should be x equals 12. And if it's just a number, you can use the braces, or you can just simply say x equals 12. Now we could kind of go on the side. I'm going to take a side rant. Maybe it's not a rant, but if I were to solve this using some Math 80 or intermediate algebra techniques, I can prove this. You don't have to because the boundary point process takes care of this. But you know, back in the past, when we were trying to solve this, we would say, okay, it's an equation that deals with rational expressions, or equation that deals with fractions. We can take each side and multiply it by the LCD. And when we do that, the denominators end up canceling out or dividing out. So we get this 6 times x minus 7 business on the left, and the 2 times x plus 3 business on the right, also known as cross multiplying. And when we go and solve it, I believe it's actually what we're dealing with. Let me make sure I'm I'm right. I'm talking at the same time as writing has always been an issue for me, but
Yeah.
we're going through this and we're saying, okay, going through a little bit of solving equations. I get 4x equals 48. And when you divide by 4, you get x equals, whoops, 12, yeah. So, I mean, you could technically go through this, you know, they call this Math 80. That's our previous math class before you take Math 114. You could go through and prove it for yourself, but the cool thing about playing with the sign analysis method is when you find the boundary points, anyone that is not dealing with the denominator ends up being a solution to your equation. So that kind of takes care of two things at once with you having to do this extra work on the side. So you wouldn't be asked to prove this. You're just kind of saying, oh, that's interesting. So is everyone okay with so far how we're getting the 12 to be a solution?
Yeah.
Yeah, I'm good.
Okay, so you can do this the longer way, or you use the sign analysis method. But now after doing all this, our goal was to solve part B, and then once you solve part B, you end up getting part C out of the way. We go back and we end up having 3 boundary points for the inequality. So let me recopy things so that everything gets a little bit clearer.
I'm sorry, I just have a quick question.
Oh, sure, no worries.
The homework, did you want us to show all of that?
What I'm looking for with the homework is probably going through the this part, the sign analysis part.
Okay, okay.
So I would actually go through all of this and then right about, let's see if I can highlight it, or I'm running out of colors. Oh, maybe right about here. From looking at your boundary point, you could tell right away that this x equals 12 is already a solution.
Okay, cool, got it.
So you could just stop there. If you wanted to show it by hand, it's up to you, but that's not necessary.
Okay, got it.
Cool. Okay, so let me copy down part B one more time just so that we can get everything in one screen and one viewing point. Part B was the 6 over x plus 3 greater than 2 over x minus 7. And we did work. We did a lot of work, a lot of algebra to get this down to a fraction compared to 0. I'm getting 4x minus 48 over the x plus 3x minus 7. Is that correct? Yes, I think so, right? Okay, yeah, just double check. Sometimes I have to look backwards on that one. So that ends up being turned into something that's greater than 0. So we did that. Red arrow was a lot of work, by the way. That's a lot of extra business. So we turned this into this. We then figured out who our boundary points were. I call them BP. We got x equals 12, x equals -3, and x equals +7. Is that okay so far?
Yeah.
Yeah.
And then we kind of noted to ourselves that these guys make the denominator 0. And that kind of gave us the reason why we chose +12 as a solution to part A. But notice it won't matter who makes the denominator 0 when you're actually solving the inequality part, because you don't have a greater than or equal to bar anyways. So anytime you see your inequality symbol when it looks like this, the automatic default, we're not going to use brackets, we're going to use the parentheses, right? I was trying to come up with the right word.
Yeah, me too.
But it's the ones that look like this, right?
Yes.
Okay, yeah. So when I see the strictly greater than symbol, there's no equal to sign. I never really have to worry about the extra part of the throwing out any solutions unless I'm solving the equation. But just it's good to know either way.
For these problems,
Uh-huh.
we have to do the sign analysis method still.
Yes.
Oh, okay.
So yeah, maybe you can model it exactly how we're doing it now, where we only have to go through one part. If you solve one of the inequalities like we're doing right now with the part B, you could automatically find the solutions to part A and part C. So it seems a lot, but it does save a little bit of time in the long run. So just kind of take your time on it. I think you guys will be good from there. But the only issue with these particular ones is that when we do the sine graph, if I'm kind of making this off to the side, I end up having 3 different boundary points. So the sine graph gets a little more exciting. I'd be plotting -3 in relation to a 7 in relation to a 12. And these are not to scale. It's just something that I'm just making sure that they are in the right order, like if we were counting. But now it breaks our number line up, not into 3 different regions, but I believe we have 4 different regions. One here, one here, one here, and then if I change another color, I think we would have here. So we have 4 different regions that we're dealing with. And it's not too horrible. I mean, there's the numbers won't get too crazy, luckily for us. But we have to remember when we're looking at our particular symbols, we're going through, we actually have not just 2 factors on the side anymore, we have 3 factors. And so you get a little more exciting because you have a few more different kinds of tests. And so this would be kind of where, if it was something you were interested in, this particular one that you were talking about factoring, that's true that there's a 4 times x minus 12. If that makes your life a little easier, you kind of have to test it out. I guess the trick would be that 4, whatever the x minus 12 ends up being, you just have to understand that it's being multiplied by a positive 4. Or if that's not interesting enough, you could just call the 4 a separate row of its own. And when you go through the sign analysis, sometimes maybe that's a little easier on the mental math aspect. And then where's my numbers? I'd have to split these all up again one more time. Give me 1 second. Oopsie. Let me see if I can do it this way. Okay. So you could look at it where, oh, okay, there's a -3, a positive 7, and it, oh, that doesn't look like a positive 7. There we go. There we go, a 12. You end up getting a few more regions to test. But when we look at where the positive 4 is, there's no x involved in this particular number. So no matter what, it's always going to be a positive 4. So you could look at it like that if that's something that you're interested in. Any preferences?
Uh,
I don't know. I mean, to me, either way seems rough, but
Just take it at 4.
So would you guys look at, I mean, we could either look at playing with the signs for the top one that we just did or playing with the signs for the bottom one. We're still going to get the same results.
yeah, I do the top one.
You guys want the top ones? Okay.
Yeah.
Okay. That's kind of the issue with where that 4 is right there. It's kind of like where you have to account for it if you end up factoring it out. Or sometimes if you don't want to factor it out, you just go through and say, let me just plug in the x to the 4x minus 48. Either way, you kind of get a calculator, but maybe the factoring helps with the math a little bit. So we'll play. Let's see how this works. If I test out, I'm going to test the yellow region out. I have to find a number that falls in that region. So what do you guys think?
And what region, I'm sorry?
Oh, the yellow region.
-10.
Negative, okay. And sometimes a lot of you will write this down right where you're doing the test point. Just be careful when you write stuff down. Don't get it confused with the boundary point because the boundary points are where your solutions come from. So don't write it too big or write it in a different color maybe. Now, if I'm plugging in the -10, I'll do this nicely. Let's go from the bottom to the top. Negative 10 minus 7 gives me
Negative 17.
negative 17. So I have a negative sign in there. Negative 10 plus 3 gives me
Negative.
negative. Cool. And now the top one, I can either say 4 times negative 10, which is negative 40, and then subtract off 48. And
So it'll be negative?
Still negative. Or I can say negative 10 minus 12 was negative to begin with, so negative times positive gives me still negative.
Mm-hmm.
So however you're doing to plug it in, it's totally fine with me. Take your time on that. Let's double check. I have it looks like you have, well, it sounds like you have a question.
I'm sorry, me?
Anyone? I just
No,
heard,
no.
Or maybe you're just like thinking, because yeah, like I said, I process the same thing the same way. Remember, I've been doing this for a very long time, so it comes a little natural. But when I'm learning something for the first time, it does take me quite a while. So we are good. Okay, so I have, and sometimes if you like, if you want to do the multiplication of the signs here so you don't forget, negative times negative times negative.
Negative.
I get a negative. Sometimes that helps because we have a lot of symbols going on. Whatever works for you guys. The next thing I'm going to do is choose a test point in the teal or blue region. What do you guys say?
0.
0 is a good one. Yeah. So then that might be a little nicer to plug in. If I go from the bottom to the top, 0 minus 7 gives me negative. 0 plus 3.
Positive.
And then 4 times 0, there we go. Minus 48 gives you negative. And then if you were to do the sign of the region, negative times positive times negative.
Negative.
So negative times positive gives me negative.
Negative. Oh, positive actually.
Negative times negative gives me positive. So just kind of be careful. Or you don't have to multiply them in the same order. You could say, oh yeah, negative times negative, and then multiply that by positive. So that tends to be some of the issues when we're going through the ones with more boundary points. We're now going to pick something in between 7 and 12. Any suggestions?
10.
10. I like 10. Okay. So now we can say 4 times 10 minus 48. I'll go from the top to the bottom. So
negative.
Negative. Okay. And then 10 plus 3.
Positive.
Positive. 10 minus 7.
Positive.
Positive. Okay, and so then now if we do the sign, the sign of the region.
This one is negative.
Negative.
Times positive. Positive gives me negative. Okay, and one more test point after the 12.
20.
20. Yeah, anything that ends with 0 is always nice for me. So if I were looking at 4 times 20, that's 80. But 80 minus 48 will
positive.
Be a positive number. And then 20 plus 3.
Positive.
Positive. 20 plus, 20 minus 7 is still
positive.
Also. And then when we do the sign of the region, positive, 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 if we all multiplication, it's going to still be positive. And if you guys notice, in this class, it looks like they alternate. So that kind of helps out with figuring out a pattern of what's supposed to happen. It's still required that you want to kind of show the proof with the signs, because sometimes strange things could happen. I'm just giving a little warning in the future, but our class, usually it's a good alternation. So now, if we have this sign graph going on, and I'll erase this bottom one because we didn't end up using it. We're looking at if we're solving part B is asking for the greater than 0, 4x minus 48 over x plus 3, x minus 7, greater than 0. So then when we see greater than 0, we're asking for where
looking
is it?
For the positives?
You got it. Hey, you guys are getting it. So if I'm asking what regions are the positive regions, it looks like there's a blue region and there's also
a purple
region. So I'm kind of just maybe color coding to help me out. And so if I were to name that, sometimes it's even helpful if I'm naming part B, I'll color in the region to help me see like the graph on the number line. So when I talk about the solution to part B, I'd be saying I'm starting up at where? For the blue, I'm starting with
-3, 7.
-3 to 7. And then if you're kind of discussing on like brackets, parentheses, when we look back at our inequality, it doesn't matter if we don't have to worry about brackets because it was strictly greater than that particular issue. So basically everything is a nice,
just regular, parentheses.
Exactly. So because we have the two different regions, there's a union going on. And then the purple region is going to be described as
12 common infinity.
12.
12 to infinity.
There you go.
And if it did have a greater than, equal to, the one that, so it would be -3 -3 and then 7 bracket.
If it was a greater than or equal to, the 12 would have the bracket.
Mm-hmm.
And the reason why we go back and we look at who the denominators are, you see the x plus 3 and the x minus 7?
Yeah.
Those are the numbers that are associated with the denominator is a -3 and a 7. Those are not allowed to be 0. So those would never have a
okay. I got it.
bracket. So only the boundary point from the numerator is going to have a bracket if there were that extra equal.
Oh, okay.
So yeah, that's the kind of catch between all of those guys. But after we solved part B, we did a lot of work with the sign analysis method. Part C, even though we didn't do all the algebra associated with it, we know part C is the same thing as part B, except for the inequality symbols flipped around. And so when you ask yourself less than 0, what are we looking for?
Negatives.
We're negative. So if we're kind of naming the regions, it looks like we have the yellow region and then what other region?
The purple. Not purple, is that pink?
The pink. Yeah, they're close. I should have changed the highlighter, but yeah, the yellow and the pink are the ones we didn't color in already. It's always the opposite of the region you answer for part B.
Okay.
That's kind of the good news, is like you don't necessarily have to do color coding. You can say, okay, well, what didn't I pick for part B? If I'm going to name the part I didn't color, the yellow region, I'm coming from, let's see, all the way from -infinity to where?
To -3.
Mm-hmm.
-3, okay.
And then 7 to 12.
7 to 12, yeah. And all of them end up having parentheses because we didn't have to worry about the brackets. So that's probably the most exciting problem of the entire section. There's so much in it, but it's good that you have an idea of how it will work. And I like to just kind of remind you of the patterns, is that part B and part C are related. You don't have to do any extra work to understand how to take the solution region. And then part A is the solution to the equation on that one. So that is the whole idea behind the 4.2 part. It's kind of algebra intense, but once you get used to the whole sign analysis method, it kind of ends up going a little faster than what it has done in the past on that.
Got it.
Cool. So, is there anything else I could answer? You have any other questions from 4.2? I know that's you're going to work on that for tomorrow.
Yeah.
Is there anything from 4.3, 4.4, or anything else? I can definitely.
I just had a question about, I don't know if this time you're going to do study guides for quizzes.
I'm not sure if it even helps, because it's kind of just taking the questions.
Mm-hmm.
I don't know if that would be, if it would cause you more harm than then just kind of looking at your homeworks and going through that. I can maybe post a chapter for a check-in maybe.
Yeah.
I can do
It's
that.
because, well, I don't have the textbook because I couldn't get it because they ran out of textbooks from the store and I couldn't find it online. So I feel like, well, for me, it'll be a little bit helpful because I can't really go to the pages and, work on the problems. So I just got the homework problems from a classmate. So
Okay.
yeah, so I mean, for me, it'll be helpful just to get it a little study guide sheet so I can work on it during the weekend.
Okay, maybe I'll go through. I think I have something that I made up for a previous class. I can't guarantee that it's like every single problem, but I think it touches on every problem, and I think it might be a good worksheet to go through. It's going to be like a PDF file. Maybe that'll help.
Yeah, that's fine.
Kind of like something I would normally give as a quiz, but since you guys are already taking the test in Canvas, it's like double work. So I'll post that. I'll do an announcement while I post the Zoom info for tomorrow's class. I think.
Okay.
I can you guys. Okay, cool. I can do that.
Thank you.
You're welcome.
Yeah,
Is there anything else? You guys are okay from here?
I'm good.
For now, at least. I understand there's a lot of stuff.
Yeah.
Okay. Well, if you think of anything else, send me a Canvas message or anything like that, or email, and I'll try to come up with more of these if I can. And
Okay.
One thing at a time. You focus on getting the 4.2 out of the way, and then maybe the next time we can get the 4.3 and the 4.4 out of the way.
Okay. Appreciate it. Have a good night. Thank you.
You too. Bye.
Thank you, Professor. Have a good one.
You too. Bye-bye.